Hello, students around the world. This is Teacher Shaddad Al-Jumini speaking. Today in this video, we are going to solve some questions about complex numbers. So, let us get started. This example or this question says, z equals 0 and 1, then z to the power 3 equals 0 and 1. Is that correct or not? First of all, before doing anything, I noticed something here in this question. What is it, teacher? Z here is written as ordered pair form. And he wants us z to the power 3 as ordered pair form. What I'm going to do is to turn this here, z, to algebra form. Why? Because I can deal or I can evaluate with algebra form, but I cannot deal with ordered pair form. So, let me remind you of something here. This is, for example, z equals 3 and -2. This is in ordered pair form, okay? I want to change this or turn it to algebra form. What I'm going to do is, this is called the real number. So still out of solve. And this is here negative. So write here negative. And here 2, write 2, but I. Why, teacher? Because the right one here means the imaginary part, and we all know that imaginary part comes with I. Okay, for example, another example here, for instance, z equals 2 and 5. Z here is written as ordered pair form. I want it in algebra form, so let us change it. This is the real number, and here we have 5, so write 5. 5 here in positive, so positive. 5, write it 5. But here, I told you here, the right one comes with I because the imaginary part, so with I. Okay, so let us get back to our problem here. Z equals 0 and 1, right? Let us change it. This is the real part, 0, so we don't have to write it. And here it is the imaginary part, so 1, and because it's an imaginary part, so it comes with I, and we don't have to write Z here. So this is Z, but in algebra form. Okay, now he wants us to find Z to the power 3, so because Z equals I, that leads to Z to the power 3 is I to the power 3. Now, we all know that I to the power 3 equals what? Negative I. Right? So now z to the power 3 equals negative I. But here, he wants us to the value of z to the power 3 in the ordered pair form. So we have to turn this to the ordered pair form. So z to the power 3 equals bracket here. Now this is imaginary part, just imaginary part. Okay, so where's the real number here? We don't have it, so 0. And here this is imaginary part, and I told you here the right one is the imaginary part. The right one is the imaginary part. So here in the right one, we have the imaginary part. But I don't have to write all of it with I. I just want the coefficient of I. Where's the coefficient of I? For example, here, where's the coefficient of 5? Where's the coefficient of I? 5. So I wrote here 5. Where's the coefficient of I here? -2. So I wrote here -2. So where's the coefficient of I here? -1. So z to the power 3 here equals 0 and -1. And it's not 0, 1. So the answer is false. I hope you understand. Let us move on to the next question. The two square roots of a complex number, which is -2i, are one of these options. So here he wants us to find the square root of this number, which is 2i. Okay, I have this rule, x plus r over 2, and here the same thing, but here -x plus r over 2. This is the square root. Now, teacher, can you tell me who's x here? Okay, I'm gonna tell you. X here is the real part. Right? Right. Teacher, tell me who's r here? What do you mean when you write r? Okay, r here means the modulus or the length. And 2 is 2. We don't have to explain it. So, here, in our numbers, it equals to -2i. So I have to find x. Where is x? I told you x is the real number. Where's the real number here? Do we have a real number? Someone is going to tell me now, teacher, real number is -2. No, I'm sorry, you are wrong right now. We don't have a real number here in this number. Why? Real number comes without I. So this is the imaginary part. We don't have here a real number. So the real number here is 0. We don't have it. So now we have to find the length here. The length here, because it's an imaginary part or a pure imaginary part, the length must be 2. And there is another way to find it. This is x squared, this is y squared. So the length equals, x here means a real part. We don't have it, so 0. 0 to the power 2 is 0. So here positive y squared. Y squared here, who's y? Y is the imaginary part. Yes, we have it here. Where is it? -2. So to the power 2, when I put the power or the square here to 0, to negative, it will disappear, and the power or the square to 2, it will be like this, to the power 2. So the length equal, the square to the negative will be positive, the square to the 2 will be 4, and we all know that square root of 4 equals negative or positive 2. So the -1 is refused because length must be positive. So this is r. Now, just fill in the blank. This is x. Where is x? 0. Write it. R. This is r. Positive 2 over 2. 0 plus anything will be the same thing. So 2 over 2 equals positive and -1. Why? Because the square root of 1 equals positive and -1. Here, where's 0? We don't have 0 here. Why? Because x here is 0, okay? So we don't have to write it in the first place, okay? So r here, the modulus or the length, which is positive 2 over 2 and plus or -1. Okay, now the result of this when x is positive will be the real part, and positive and negative. Here, when x is negative, the imaginary part. So 1 I. So we don't have to write 1, okay? But if we have here 2, we have to write 2, okay? Don't forget it. But here in the result, 1, so I. So the result of this must be imaginary part. The result of this must be the real part, okay? Do we have anything else? Yeah. We don't, finish yet. So take positive and negative here, and this is 1 still here, this is I still here, and what's the sign here? The sign here is the same sign in the imaginary part in the main problem, in the main number. Where's the main number? This z equals negative 2i, and this is the imaginary part. What the sign here? What do you see? Negative, so it will be here negative. So this is the right answer, positive and negative 1, negative I. Where is it? Positive and negative 1, negative I. So yeah, this is the correct answer too. Do you understand?